people, maybe I like it. Okay, remember the agenda? Go the second part now. I talk around what is the connectivity inside the cluster. And now starting how the outside world ingress, see, consume my application. This concept originally doesn't exist. The ingress was an add-on in the second version to the cluster inside. And now the old ingress is changing again for another open source project talking Gateway API. If you go in deeper with this discussion, you have Las Vegas session around what is ingress and Gateway API, or Barcelona session, you go to deeper. This is an introduction, no go too much in deeper. Okay. What is the problem? The people say, I need a load balancer. Yeah, nothing more than load balancer. You need a load balancer, local load balancer, global load balancer, offload for the old SSL, now TLS. You have IPAM, I need WAF, I need. So in this is not only just a load balancer you need for the application. And the problem, when you see this, is, okay, is enough a layer 4 balancer? Yeah, no. Why not? Because I have a WAF, I have a record for the global in the DNS. Maybe I need handle what is IP, and with this IP, create the name, and the name create the register in DNS. It's okay? No, because above that, maybe you know the global, because we have the same name with two different DNS record, but I need the intelligence is live, not live, no. This is what you need really for the application. Forget this is Kubernetes. When you're talking in a traditional VMs application, it's the same. The problem is no load balance. You need solve all problems in the same time. Doesn't matter a VM, doesn't matter it's a cloud native. You need a load balancer, an IPAN, and WAF, and on, and on, and on. What is the problem? I have open source for working with this? Of course. I have, you remember my 2-page for project for the CNF? Yes, I have project for each step. I'm working, of course. You put your time, you working, it's ready, perfect. 2 weeks then, you have a new version for some component. And it's possible update and still working? I don't know. The problem with the open source is not the day 0. It's the day 2 problem. The operation when you need update some piece in the old stack, is still working or no? You have time. And you have time and maybe prime when they're talking something, the application is still running. Yeah, sorry, but this is true. What is the concept? A single tool. That is the idea with AVI. AVI is a single tool to provide all capabilities you need for your application. In this case, for cloud native. In this case, for Kubernetes side. Because inside AVI, you have a load balancer, locally, globally, a WAF, an IPAM, an DNS. So you upgrade the AVI, you upgrade all capabilities in the same. It's tested, it's enterprise grade. Please, I don't say open source is bad. The open source need time for each people testing each component and see, go ahead. And you have time, you have space to test in everything option? Normally no. So the idea is more easy for or in day 2 operation something more easy to ingest. And that's the idea with the AVI. What is the idea with the concept, the AVI? Is put the same AVI service engine outside the cluster of Kubernetes. So the same AVI service engine, balance of VMs, physical stuff, whatever, include tools, and inside the cluster, the Kubernetes cluster, and put an operator. Operator. Operator is a capability to extend the API in the side, the Kubernetes, and our case is starting to see when the SHA-5 say, I need a service load balancer, I need an ingress. I take in that information, and provide that information to create from the control plane to create my service. So I put a small piece for control plane proxy between the Kubernetes and the control plane for the ABI. It's not running inside, it's outside. Don't compete with the other resource. If you have load balancer service and a small part for control plane integration between the Kubernetes and the ABI service. First combination, ABI Kubernetes operator, AKO, the name, sorry. So the idea is, again, is a small part seeing the API and see when some people send me a message to request a load balancer, request an ingress. I capture that request and deliver this information for the control plane for the ABI and create the service for that case. In that case, the idea is you developers, the AKO, the watching people seeing my request, and it's ready. Watching, seeing, hearing, whatever you like. But my glass is put seeing that request. When I see some people request me, I need an ingress, a load balancer, I take in that information, talk with the control plane, and create the IP and DNS record, and prepare the VIPs in the service engine. So you have ready. Waiting for consume, but you have ready. For this guy, nothing changed. The people create a sham file or maybe Argo CD or whatever tool to integrate on the developer, but inside that, you have some ingress or load balancer concept and taking that portion and create everything in the stack to provide. In this case, DNS EPAM. If you have WAF, it's possible in the sham file, mark the name of the WAF policy, and you put the WAF policy to the ABI to that service. For the developer team, sham files, Argo CD, or whatever, usually consume, nothing changed. For us, I see, I have control, I have the power. In the same concept, when you ready the client, go to the DNS, okay, who is the IP address for this name for the application? The ABI say, it's this IP. With this IP, with the load balancer to the server pool. And who is the server pool? The pods inside the Kubernetes. The change for us, in the traditional way, the server pool maybe is an IP, a VM, a physical server. Now for us is something named pod. But the rest of the concept is exactly the same. What is the magic? This connection is the magic. How each bit knows where is the IP in the server pool inside the pod because the IP changed. And that is the idea, the operator. If everything is okay, the answer from the pod go to the BIP and the BIP to the user. Nothing strange. You believe in this local load balancer? What happens when you need balancer in different clusters? You remember the global size selector or global load balancer? It's the same concept. What is here is possible to create a DNS record to point in two different IP addresses in two different sites, maybe an on-premise, maybe in another place, and balance the application. Yeah, you balance the ingress. You don't balance the backend. The backend is problem for the cluster Kubernetes. For me, it's the ingress, who the people consume me. And it's possible to use the same API, yeah. And for the DevOps team, it's just put in the sham file an entry, GSLB, ... something. So I explain this application live in two different sites, share the same name, but you have two different VIPs. And it's possible for you, us, taking the ABI control and taking my policy, maybe select for country, maybe select for, I don't know, IP source, whatever, the normal thing you create in a global load balancer. The DevOps team know something that? No, it's transparent for them. She's put Argo CD, sham file, wherever, I have the control how balancer this because the AV control is my stuff. It's a network and security stuff. Let me more quickly. And you say from the VIP to outside is the common way. Nothing strange. I see the magic is why the VIP to the pods. Okay, why is the magic? Because you have different options about when you're talking about CNI. When you're talking about CNI, you have the external world don't know the IP address for the pod. It's something completely inside. Okay, I have IP, it's possible running inside, but in some moment I need to go to outside. And that idea is taking the worker, because the worker is connected to the outside world, has an IP routable in the inside world, and so it's possible taking the IP using source net and convert that destination to the worker to inside a pod. The first case is no port. No port what means? Means I have this pod. I don't know it's working, it's running in this, and this, and this, and this, and end this worker, I don't know where really run. But expose in all pod the same ports to the outside world. So the load balancer only needs the IP and the port and provide. But I don't know it's running here or running there or running, so it's okay. You don't need a stale. You need some stateless capability, it's okay. But if you need a stick it, it's a problem because you don't know really where is the pod. You possible go to this worker and the worker decide move it to the next one. So it's easy, but for very, very basic load balancer. So, okay, and when you need stateless, oh, I have the other option, cluster IP. It's an expose an IP, and the IP is see it in external network, and it's possible see the IP and balancer things, but I need way to directly connect static routing to go to each pod. Work? Yeah, work is okay, because when I select that pod, I know the IP the pod, so the IP port is inside for the AVI, is routable, it's not only inside, I see it, so I need handle the IP range for this pod, because it's something I go to routing almost from the service engine to the pod. It's possible to stay full service, yes. It's possible to layer 7 and stick it, yes, WAF, whatever, but you need handle the IP address for each pod like in static routing. No, operator create the static route for you. You don't create in handler manually. That is the idea, but it's other option. The last one is when you use Antria. With Antria, it's possible to create a mix in both sides. So you have the same consent for node port, but only one node port is locally for this pod. So expose the IP for source NAT, but only in the worker when you have a pod. And this is a one-to-one source NAT. And this idea is still, I don't know the IP in the pod, I see only the worker IP, but each pod is one-on-one in this IP and port. So it's possible to combine. Doesn't matter the IP inside the pod, but I have the possibility to see the sticket for each pod. It's nice because it's 4 pod, but the constraint, of course, you need Antria. Normally, for other CNI, you use it, cluster IP or no port, depend the case. For no port local, it's required Antria. That's the important line. Okay. Go a small port. Service mesh. What means service mesh? The problem when you have microservice, a lot microservice, is each microservice needs talking with another. Microservice, for us, equal a pod. A pod is a microservice is a pod. for connectivity things in between. What is the problem? You need to extend this connectivity in each pod, maybe 10 or maybe 100 pods to connectivity. And you need something handle this connectivity not only in clear text. Maybe you need something to protect the connectivity between each pod. What is the idea? Maybe use something encryption inside each pod. But the problem with each pod is maybe create with different framework developers. So you need the same library for encryption in each different language to produce the same thing in the connectivity. Perfect. What is the easy way? Maybe something TLS. Okay, TLS is perfect. Yeah, and you have a problem. Certificate. How problem has changing certificates in some application? Yeah? Thinking this problem in not one, in 100 points to handle. What is the idea inside? Simplify this. So the idea is create a secure connectivity, a visibility, and maybe a compliance part. The idea is create a small proxy, light proxy, a sidecard inside each pod. So my pod has my container application and a small part handle the connectivity. So the developers need to know what is the library to encryption. Doesn't matter. It's my problem. It's network provide a secure connectivity in between each pod. That is the idea, with service mesh. And provide not only that connectivity, handle the life cycle of the connectivity, rotate certificates, rotate the expiration, and mutual authentication. Not only client-server, it's mutual. So I am done, and you provide your information is trusted in both ways, not on one way, usually one client-server. That is the idea. It's a true close. This concept is service mesh. You create this platform to connect different clusters in different places in the world, not only in the on-premise. It's possible to run something on-premise, something in some public cloud, yeah, is supported. And the application is expanded in different clusters in different places. Not the cluster. The cluster still remain in each place. It's possible to use the runtime in on-premise, AKS, IKS, wherever, and put something, the application know the magic to connect different components in different places. That is possible? Yeah. But the idea is now, for us, is not create a static IPsec VPNs maybe. It's create a fabric to connectivity between different clusters of kernel in different places in the world. And in an easy way, not manually, provide something has automates delivery, automates certification updated. The life cycle is included in the idea. Again, it's not 1 or 10 connectivity. Maybe it's 100 endpoints to handle. We need something automate these rules. And this is possible to create and handle the connectivity similar with the network policy, but between different pods in cluster in the world. And it's possible to create not only the handle the MTLS, also provide, for example, because you live in the same pod, but before go to the network, from the application container, I receive in clear text the information. Because it's inside the pod, it's like inside a VM, I can see, but when they go to the outside world, it's encrypted. But this visibility allows me to see not only what is allowed or not allowed, similar distributed firewall, similar to network policy, but in big way, but also allowed me to see what happened inside the packet. Not because the packet is here in the network, because I live here inside the pod. So before go to the network, I take in the information here, and it's possible checking what this information is. Here, it's encrypted. That is the idea. But before that is encrypted, I had a point to control. That's the idea with the service mesh. So for the people need something special, it's possible included, combine both service, and you remember the load balancer to define what happened, and maybe you have an application expand in different cluster Kubernetes. So it's possible to combine the ABI, load balancer, with the Tanzu service mesh, maybe in two different regions, or maybe in the single region and do different ability zone. You remember the VCF starting in my discussion? Two regions, do VCF instance. One region, one VCF instance with two different application ability zone. I come back in the beginning, but with the same tools. It's another possibility. The last topic is something strange. You remember my first slide about the application running in container and pods, but the database running in a VM? What happened is possible to create a database service like a pod. So, no handle create the VM. In the same topic, the same style, YAML file, I create the pod, I create a data service, a database. That's the idea. This concept, data service manager, is included in VCF. What means? It's a MySQL or maybe PostgreSQL, normal, but I create these VMs in maybe one single VM, maybe two VMs, a cluster, or three VMs, a cluster, but in a single shot, one YAML file, like a pod. It's still a VM, but in the same CD, Argo CD, the same people thinking like a pod, but now for database service. And that is the end part, what is now automated for the people. You prepare the VCF environment to define and protect and backup, because it's my responsibility taking the backup and other stuff, but deliver the option to the DevOps team, create a real database. And this concept is okay for maybe basic application. But when you see VMware private AI, you need some database. That database needs handle a cloud native application. Some database needs something, a vector database. And that vector database is MySQL. Sorry, PostgreSQL. So it's only for database, or maybe when you go to private AI, this service start to taking this rack. You see private AI, the rack is taking the concept and improve the prompt to go to the Elm. That's the idea is you have a vector database, and that vector database is supported with PostgreSQL, and this is a step 0 for that idea. Maybe only for this, but it's possible to automate. And finish. Freeze. I know. For us, network and security teams, maybe see Kubernetes is something in a black box. But it's not black box. The same concept to connectivity, one point with another point, still exists. But the way that work at Kubernetes clusters is different than legacy application. So we need understood what is the difference, but we need learn. Why? If the people go to only deploy application and don't care what is the network, and don't care what is the load balancer, and don't care what is the security, the problem happening in some moment. And what happening, I see, and what is inside that black box? Starting now. Starting to learn, to understand what is the DevOps team talking about, who is service mesh, who is ingress, who is CNI. If I take in the information now, it's more easy to go to the future, especially for us. If you look this session, tomorrow I have another topic, completely different, talking about VCF security, VDefend, but with the focus what see in the field with the ransom ransomware troubles. And si alguien habla español o es castellano, podemos hablar después. Please don't forget the survive, and thank you for your time.